All right, today we're on Chapter 3, Polynomial and Rational Functions, and this is Section 3.4 on graphs of polynomial functions. So again, what are polynomial functions? Well, they're smooth graphs with no sharp corners or breaks, and our domain is basically all real numbers, so all x values, okay? Now multiplicity, that's a new one. What is that? So it's a number of times a factor appears in a factored form of the polynomial function. So, say maybe we have x plus 3 squared times x minus 4 to the third, and that's what our f of x is equal to. So that's our function. And in the factored form, our multiplicity is going to be our exponents, okay? So in this case, this is done twice, so that's 2 times. This one's done 3 times, so there's 3 as a multiplicity here. Now what we're going to do is we're going to use factoring to get it to this stage and the zero product rule to find our x-intercepts of the polynomial function. So basically, each one of these we can set equal to 0, and that's going to tell us the x-intercept. And then we can find the multiplicity of it by looking at the number of the exponent, okay? So if we look here, we need to find x or t or whatever our variable is, intercept, and we also need to find the multiplicity. All right, well, looking at these, first let's find our intercepts. So if we look at that, that's a factor, and that's a factor. So we're going to set each of those equal to 0. So for t equals 0, so t equals 0 is one of my factors. And so if that's the case, then I'm going to have 0, 0. Okay. What if I set this one equal to 0? T minus 2 equals 0. Well, here t is equal to 2, so I have a 2 comma 0. So that's my intercept. And my last one, I have t plus 1 equals 0, so t equals a negative 1. All right, and so I have negative 1 comma 0. So those are my x-intercepts. Okay, so it's also the y-intercept in this case, but those are the x-intercepts. All right, now we need to find the multiplicity. Well, this one, t to the first, that has a multiplicity, and let's just write multiplicity, we'll just put mult, and here that's 1, okay? So that's equal to 1. And here we have 2, so that's equal to 2. And here we have just a 1, and so the multiplicity is 1. Okay, so we found our intercepts and we have found our multiplicity, and that's what we have to do. Now this one given, it's already factored, so we didn't have to do any work, but we had to then take that down and then find our x-intercepts and find our multiplicity. So what does that mean? Our next ones we are going to have to factor. All right, well that's not hard here. So factoring the first one, what I'm going to do is I look and I see there's an x in all of them. So I can pull out an x, and then I have x squared plus 6x minus 7. Now, can I factor this? Well, that's going to be x, and well, it's going to have an x and an x for the x squared, and 7 is 7 and 1. Now I have to have a positive 6 in the middle, and I have to make this a negative. So one's going to be positive, one's going to be negative, and the larger has to be positive. So it's plus 7 minus 1. So that gives me x squared plus 7x minus x gives me 6x, then minus 7. So that is my factored form now. And now again, I'm going to want to find the zeros. So set each of those equal to 0. So I have x equals 0. I have x plus 7 equals 0, and I have x minus 1 equals 0. So with this one, I get the 0, 0. Okay. What about the next one? Well, I get x. Well, I guess since that's already there, so here I get x equals a negative 7, and so I get a negative 7, 0. Okay. And here x minus 1 equals 0. Oh, well, I already wrote that. So x equals 1, and so I have 1 comma 0. Okay. Now multiplicity, what do we get? Well, they all just have 1, so they're all equal to 1. Wow, writing extra stuff here today. So they're all equal to 1 for the multiplicity. So that one is not hard, okay? Now the next one, what do we do here? Well, these, if we look at them, look like maybe they're perfect squares. And so that's going to be x. And we have a 2x, and factoring the 9, we have a 3. And then it's going to be a positive here, but negative here, so it has to be minus. And there's going to be 2 of them. and this is going to be x plus 4 squared. Again, we just have to realize what the form is, and those are perfect squares. And so it's 2x minus 3, the quantity squared, and x plus 4, the quantity squared. And so that gives us x equals 0, 2x minus 3 equals 0, and x plus 4 equals 0. So we get 0, 0. Here, if we take the 3 over, we get 3 divided by 2 is 3 halves, 0. And here we take the 4 over and we get negative 4, 0. Okay. So those are our x-intercepts. Now multiplicity. All right, well, let's write that over here. Well, here, that's just equal to, there's only one of those, so that's 1. Here, well, we have 2 of those and 2 of those. So both of these then are equal to 2 for our multiplicity. Okay. So, sometimes we get, all ones, sometimes we get a 1 and a 2 and a 2. You can get 3s and 4s and 6s and 8s and 9s and whatever. It could be anything. And what we do is we just have to write, that multiplicity. And what's going to do is eventually we can be able to graph this just looking at what we have here, and we can graph it. Now it's just going to be kind of a rough sketch graph, of course, but we can actually graph these. Okay. All right, so let's stop there and I'll come back.